Okay, welcome back. So we'll start solving some problems now. Today we'll focus on the primary trig ratios, so sine, cos, and tan. And of course, we mentioned before Sohcahtoa. Hopefully, with that you can remember how to calculate sine, cos, and tan. Obviously, somehow you need to remember that. Whether again it's making up your own little mnemonic or just knowing Sohcahtoa will be fine as well. So if we look at example 1 here, I'm clearly looking for this missing x value. What's important to note is that in order to solve any triangle, I need to have 3 pieces of information. And here I have 3. I know 2 of the angles, one is 90, one is 35. Hopefully you recognize that would allow me to find this one as well, but in this case, that's not necessary. And of course the 25, I need at least one side, or else I can't solve these as well. So let's go through. When I'm looking at this, I see 35 as my starting point, and so I'm going to do some sort of ratio with the 35. The x that I want to know, that I need to include because I'm trying to find it, is my adjacent. The 25 that I do know is my hypotenuse, and so pretty straightforwardly, cos of 35 from the idea. Cos of 35 is my adjacent over my hypotenuse. And now I solve this like any equation. I want to isolate x. I'm dividing by 25. And so essentially what I'm going to do is multiply both sides by that same 25. And of course that maintains the balance of my equation. Both sides are now 25 times bigger than they were, so they're still equal to each other. What happens is, of course, that cancellation over there, and then 25 times cos 35 will get me my answer. And assuming I did it correctly, albeit quickly, 20.5 is approximately my answer. So if this is 25 up here, I've got 20.5 for my x. So again, pretty straightforward stuff. Example 2, looking at this. Now, I put this example up to make a point. It looks to me, when I see this diagram, if I didn't see the actual numbers that were in there, this diagram looks like an isosceles triangle. There's no indication of that. And so when I see these numbers, I have to assume that the numbers are correct and the diagram, the appearance of the diagram is not. So you want to be careful to recognize, even if I had put in some much larger number in one spot, which I guess I did, or if I'd put numbers that were in any way indicating something in the diagram didn't look right, always trust the numbers. That said, too, the fact that this looks like a 90-degree triangle, but it's not indicated, I'm going to assume it's not. Okay, so when I look at the diagram, try to solve it, I see I have a 12 here, I have a 50 here, I want the x up here, but I don't know anything really about these angles inside the triangle. Again, they look like some of them are similar. Clearly, based on the numbers, they are not. It looks like this is a 90-degree angle in that spot here, but there's nothing that really tells me it is. So as far as using the primary ratios here, basically, at this point, this question is impossible for me. If all I have available to me are the primary ratios, then this question is impossible, since there is no right angle. Okay, so just sort of making the point, trust the numbers that you see, trust the information on the diagram, but don't trust the actual appearance of the triangle. On a test, I will copy and paste my triangle 6 times, 8 times, 3 times, however many times I need it. It will be exactly the same triangle, and I'll plug in different numbers for you to work with. Now, one word problem, just to kind of get the idea. Jane is on the edge of a cliff. She looks down at an angle of depression of 30 degrees to see a pond. Assuming the cliff is 55 meters tall, how far out must she jump in order to land in the pond? Okay, so kind of an important idea here that comes up throughout most or throughout a lot of questions is angle of depression. Angle of depression is the angle below the horizon when you look down. Angle of inclination is the angle above the horizon when you look up. Okay, so essentially what we're saying is if this is our hero, let's assume he has a ball cap because that's what makes people a hero. The angle of the angle of inclination would be from the horizon this angle here. If he's tipping his head backwards or he's looking up with his eyes, that would be an angle of inclination. Similarly then, if he were looking down, the angle that I'm given is this one for an angle of depression. Okay, so just sort of trying to make sure we recognize what those two things mean. It's how much do you go down from what you would have been looking at for angle of depression. So, if I continue on then to worry about Jane, I'll just delete it, I guess. So Jane is on a cliff, and the cliff is 55 meters tall. Now, one of the things that happens with any kind of a word problem, we make assumptions. When Jane's height is not mentioned in this question, what I'm going to assume is her height is insignificant with relation to the rest of the question. Really what this is suggesting is probably Jane is lying down right here, and so the actual height, no, it's not really suggesting that, but the way the question is worded, that's the way I will treat it, as if her head is actually right at that 55 meter mark. Clearly that's not really a sensible case, but that's what I have to assume based on the numbers that are given to me and the fact that I don't know anything about Jane's height. So my pond is down here now, and essentially what it's asking me is how far away is the pond from the base? How far out would she have to jump in order to make sure she lands in the pond? And then the last thing, the angle of depression, of course, we just discussed. Angle of depression essentially is going to be, oops, should probably get my line of sight to actually hit where I want it to hit. The angle of depression ends up being that angle in there. Okay, so we want to just make sure that as we're developing the diagram, we take the information that's given to us and put it in the right spot. So that's essentially what my diagram looks like. Now, all that said, I'm going to have a triangle right here, which is really what I'm looking to find or looking to work with. I know the 55 is over here. I know the X is here. In this case, because it's telling me the cliff has a height of 55 meters, I can assume there's a right angle in it. Like anything else, when we talk about height, we talk about straight up and down height. Nobody tells me that they're shorter when they're sitting down than they were when they were standing up. I ask the question, how tall are you? I get the answer 5'8". I get the answer 5'8" whether the person's sitting on a bench, sitting on the floor, standing up, walking. That's their height. Their height is the straight up and down height, bottom to top. Now, the one thing that I don't have yet is that I don't have that third piece of information just yet. I have the 55 as one piece of information. The right angle is two pieces of information, and I need a third in order to solve for the missing X. Well, the 30 degrees here was not in my triangle, but it does help me find information that goes in the triangle. And there are actually two different ways I could use this. The first one is recognizing that if that's the straight out height, or straight out, sorry, distance, the horizon, that's the straight up and down height. that ends up being a right angle triangle. Or sorry, right angle, not triangle at all. Which means that if it's 30 on the outside here, I have a 60 in that spot right there. So just kind of the logic of horizon straight out, height straight down, tells me that that 30 on the outside can help me get the 60 on the inside. I could also think of it in terms of this angle right here, kind of forming a Z angle situation all the way to the bottom there. And just in case that's not super clear, that's our Z angle for parallel lines. This is the ground down here, which is straight, again, assumed to be straight. This is the horizon, which is assumed to be, or by definition is, straight out. And so the 30 from here, and gives me a 30 down here as well, which works nicely with the fact that we already said the other one was 60. Okay, so sort of getting to that point where I have my whole triangle set up is a matter of deciphering a little bit of how this 30 is going to help me get one of the other two angles. And which one of these you choose, the 30 or the 60, just depends on which one you're more comfortable finding. You don't have to find them both, of course. So then I can finally finish up the question. I'll work with the 60 degrees for now. From that 60 degrees, I have my adjacent, I want my opposite, and so I'm basically looking at tan of 60 being the opposite over the adjacent. As we saw before, that means I have to multiply my 55, multiply both sides by 55. I get the 55 canceling on the right side, and so I end up with a pretty hefty jump to try to make here. 95.2, 95.3, I guess. Meters is approximately my value of x. If I had taken it with the other way, if I'd gone from the 30 specifically, I'm looking then at an opposite over here, an adjacent down here, and so once again it's tan of 30 this time, will be the opposite, the 55, over the adjacent, the x. And you'll notice maybe I have a little bit more work this time. Now I need to multiply both sides by the x, and so I end up with x times tan 30 is equal to 55. Again, the x on the right side when I multiply will just cancel. And then essentially I'm going to divide through by the tan 30. And assuming I haven't done anything silly, I should get exactly the same answer. .3. Okay, so just a few things I wanted to cover there. The idea that angle of depression and angle of elevation, angle of inclination, angle of elevation is actually another word that you may see. Just thinking about it off the top of my head, and didn't even mean to say that, but angle of elevation would be the same sort of thing as angle of inclination. Depending on which textbook you're looking at, it may give you one or the other. So recognizing which one of those two things you've got, and then understanding that depression specifically is often not in our triangle. If I was looking at the angle of elevation or the angle of inclination from this point down here, it actually would likely be part of the triangle that I'm trying to solve. And of course, how that angle of depression allows us to work is with a Z angle or with sort of a right angle to find the missing values in one of those two situations. So we'll call that quits.